Hello 10thers, welcome to Isha Schools. In the last video, we had learned about the geometrical meaning of the zeros of the polynomial using 1 zeros, that is linear equations, 2 zeros, that is quadratic equations, 3 zeros using cubical polynomials. Now today, let us just do the examples of this chapter using the concept which we had learned in the last video. Alright, now in the last video we learned 1, 2 and 3 zeros of the linear, quadratic and cubic polynomials. But now I haven't told you about where the zeros don't exist at all. There are no zeros of the polynomial. Now, how should that graph be? Suppose in the graph, we have, this is x, this is y, negative x, 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Similarly, negative 1, negative 2 for negative x-axis, minus 4. Suppose I have a graph which is in shape of a parabola. So this shape is called parabola. Now, if the graph is in shape of parabola, which is not touching the x-axis at all, it is not touching, it is only in the y-axis till the point 1. It is not touching the x-axis at all. In this case, we say that it has, this particular graph has no zeros of the polynomial because it is not touching the x-axis at all. Let us take another graph where x, y, negative x, negative y. Minus 4, minus 3, minus 2, minus 1. 1, 2, 3, 4. Positive y-axis again the same. Now, negative x-axis, same. Now, suppose I have the inverted parabola. Alright, now here also the graph, it is not touching the x-axis at all. So, in this case also, there are no zeros of this particular polynomial graph. No zeros. So, unless the polynomial graph touches the x-axis, there will be no zeros of the polynomial. Alright? Alright. Now we come to the next. We will take individual graphs of the example 1. One by one, I'll be explaining it to you how many zeros. Just see the question. Each of this graph is y is equal to px. That means y is a polynomial in x. Where px is a polynomial, for each graphs, find the number of zeros of px. You have to just look at the graph and find out how many zeros of the polynomial does it have. Of the polynomial what? Polynomial px. Now this is the graph given of the first sum. Now here we can see that it is touching the x-axis only at one point. Only at one point. So, it is touching the graph at only one point. So, how many zeros of the polynomial? I need answer from your side. Correct. 1 0 of the polynomial. Only 1 0. This polynomial has only 1 0. Why? Now in the book it is written y. So why is it only 1, 0? Because the graph is touching only at one point on the x-axis. These are all geometrical meaning of zeros of the polynomial. Whenever the graph comes, it is always the geometrical meaning. Now in the second graph, now this is also an inverted parabola, but the graph is touching at 2 points on the x-axis. Of course, one is in the negative side, one is in the positive side. So what? It is touching the x-axis. Maybe negative, maybe positive, but touching the x-axis. Since it is touching, this particular parabola is touching the x-axis at 2 points. It has how many zeros of the polynomial, children? Yes, absolutely right. 2 zeros of the given polynomial px. It has 2 zeros. Now why? In the book it is given y. Why? Because the graph, the inverted parabola, is touching the x-axis at 2 points. Is it perfect? Very good. Now coming to the third. This is a graph. I need to know from your side, students, the graph touches at how many points? 1, 2, 3. You are absolutely right. 3 points. The graph touches the x-axis, negative x-axis at 1 point, positive x-axis at 2 points. So total 3 points. So when the graph touches the x-axis at 3 points of the given polynomial px, then it has 3 zeros. So the answer is 3 zeros. Question asked, how many zeros? So it has 3 zeros. Alright. Now why? In the book for everything it is written y. Now why? Because the particular graph given in part 3 of the question, it touches x-axis at 3 points. So it has 3 zeros of the polynomial px. Now coming to the next. Now this is a linear graph. One straight line. So one straight line, so linear graph. Now it touches x-axis at how many? Of course it touches y-axis here, but we are not concerned with the y-axis, isn't it? We are only concerned because the question is find the number of zeros. We are concerned only with the x-axis. It touches the x-axis at 1 point. So the zeros of the polynomial is only 1. This particular graph, the particular polynomial px has only 1 zero. So you will write it has only 1 zero. Alright, great. So now coming to the next. Now this is a parabola touching the x-axis, isn't it? Now touching the x-axis exactly at this point, isn't it? At this point. So how many zeros does it have? I want the answer from you. Correct. It has only 1 zero of the polynomial. So it's so easy for the graphical representation or the geometrical representation for the number of zeros. Just see at how many points the particular graph cuts the x-axis. That many zeros. That is the simple method. Alright? Okay. Now, look at this. Yes. Please tell me how many points does it cut? 1, 2, 3, 4. It cuts the x-axis at 4 points. So how many zeros of the polynomial? Correct. It has, the particular polynomial has 4 zeros. So this graph, the sixth question of the graph, cuts the x-axis at 4 points. 1 in the negative x-axis, 3 in the positive x-axis. Together it makes 4. So 4 zeros of the polynomial. So 4 zeros, why? Because this particular graph cuts the x-axis at 4 points. So that is why it has 4 zeros of the polynomial. I think it is absolutely clear, the graphical representation of finding the zeros of the polynomial. Very good. All right, now we come to the exercises. After we finish the whole of the examples, which are the guidelines to solve the sums given in the exercise, we now come to the exercise 2.1, where the graphs are given and we need to find the number of zeros of the polynomial px in each case. All right, so in each case, first of all the answers have to be done by you students, isn't it? Now you have to tell me whether with how many number of zeros does each of the graphic polynomial has. Now the first graph, the first bit, the graph is just parallel to x-axis, not touching the x-axis at all. Yes, please tell me the answer. How many zeros? Part 1? Correct. Part 1 has 1 0. Absolutely right. Now coming to the second part of the graph. Here the graph cuts the x-axis at this point, only 1 point. How many zeros, students? 1. Absolutely right. So the second part has 1 0. Correct. Now coming to the third part. Now here the graph cuts at 1, 2, 3. 3 points on the x-axis. So how many zeros? Correct. 3 zeros. Part 3 of the question has 3 zeros. Absolutely right. Coming to the fourth part. Now fourth part of the question, though negative x-axis, it cuts at 2 points. So what? It is negative, but it is counting x-axis, isn't it? So 2 points. So how many zeros? Correct. 2 zeros. All right? Great. Now coming to the fifth part of the question. 1, 2, 3, 4. Cutting the x-axis at 4 points. 2 in the positive, 2 in the negative. Together it makes 4. So what is the answer? How many zeros? Yes, 4 zeros. 4 zeros. Fifth part of the question says that it has 4 zeros of the polynomial px. Coming to the sixth part, the final part. How much? 1, 2, 3. 3. Cutting the x-axis at 3 points. 2 in the negative, 1 in the positive. Total is 3. So it is cutting at 3 points. The last part of the question, how many zeros? Correct. 3 zeros. Absolutely right. 3 zeros of the polynomial. So I have seen you have understood it very well. The geometrical representation of zeros of the polynomial. Is it absolutely clear, children? All right. Now let us move to the next part. This is relationship between zeros and coefficients of a polynomial. I have told you the coefficient means for a variable, the coefficient is the number. For example, coefficient of x square is 2. Coefficient of x is minus 8. Here the children make mistake of not writing the negative sign. Please remember, it's very important. Whenever you write the coefficients, it has to be along with the sign. Now plus sign, of course, we don't write. So we write only the number. Now when it is negative, you need to write negative sign and it is compulsory. So coefficient of x is minus 8. So the topic says relationship between zeros and coefficients. Now with this example, first of all, let us take out the zeros. How do we take out the zeros of the polynomial? It is a quadratic equation. Now the quadratic equation zeros, we need to solve for x and equate it to 0. So we get two forms of x, we equate that to 0. In the last video we had done for linear polynomial where we had equated it to 0. So we find the zeros of the polynomial by solving the equation x to equating it to 0. Alright, so let us do that. 2x square minus 8x plus 6. Now, how do we solve it? 2 6 are 12. We need 12. So 2x square. How do we 12? How do we divide for to get 8? 4 6 2s are 12. Correct. Now why do we take only 6 2s are? We can take 4 3s are 12 also. But we can't take 4 3s are. Why? Because 4 plus 3 is 7. And 6 plus 2 is 8. Our requirement is 8. So we can take only 6 and 2. Okay. And please remember, here is a negative sign. So whenever we take negative sign, we need to see that the greater number has to have a negative sign. Then only this will satisfy the equation. Alright, so 2x square minus 2x minus 6x. So minus 2x minus 6x forms minus 8x. So 2 and 6 are taken plus 6. So now I write like this, underline for convenience. Now that implies 2x taken common, x minus 1. Minus 6 taken common, x minus 1. That implies 2x minus 6, x minus 1. Now to find zeros of the polynomial, we equate this to 0. Now when we equate, we get 2x minus 6 equals to 0 implies 2x is equal to 6, x equals to 6 by 2, that is 3. X is 3. And here x minus 1 is equal to 0 implies x is equal to 1. Alright. So we get the zeros of the polynomial as 3 and 1. The value of x is 3, the value of x is 1. So because it is a quadratic equation as discussed earlier, we have to have two zeros of the polynomial and we got it already, 3 and 1. Now I come to the main part of the question, which is relationship between zeros and coefficients. Now zeros are 3 and 1. Now sum of zeros, Now relationship means sum and product. These are the two things we find out, and see how is it related to the coefficients given in the question. Sum of zeros is 3 plus 1, that is 4. Alright, now 4. Now where do we get 4? How do we get 4? 4 by 1. And product of zeros, 3 into 1, that is 3. 3 by 1. Now, the given equation, I can write it 2 bracket x square minus 4x plus 3. I can take 2 common. So, our equation becomes, now when we equate to 0, the 2 becomes 0. So, we get x square minus 4x plus 3. Our equation is this. Alright. Now, which is in the form ax square plus bx plus c. Alright. Now, with this, what is the value of A? 1. What is the value of B? Minus 4. Please don't forget to write the negative sign. Minus 4. What is the value of C, which is a constant? 3. Now, when we are doing the sum of zeros, it is coming 4 by 1. Alright, 4 by 1. Now, 4 by 1, what is that? See, now this is zeros. We have to relate with coefficients. Now, what is the coefficient? 4 by 1. A is 1. And B is minus 4. So, that means 1 negative sign. And 4 is where? The coefficient of x. So, minus coefficient of x by, now here by 1. 1, where do we get 1? A. What is A? Coefficient of x square. So, minus coefficient of x by coefficient of x square. This is what is the question. We are relating the zeros with the coefficients. So, sum of zeros is minus of, this minus is very, very important, coefficient of x whole by coefficient of x square. Alright. So, now coefficient of x means, in general, what is the coefficient of x? B. Very good children. Minus b. What is coefficient of x square in general? A. Minus b by a. So, what do we get? The relationship, the first relationship between the zeros and the coefficients of the given polynomial 2x square minus 8x plus 6. That is, sum of zeros is minus coefficient of x by coefficient of x square. That is equal to minus b by a. Now, let us see product of zeros. There are two relationships, isn't it? Sum and product. We have finished with the sum. Now let us do with the product. Product of zeros is 3 by 1. Where is 3? Constant. Our constant term is 3. So, what is the relationship with the coefficients? Constant term whole by, now 1. What is the value of, 1 is the value of x square, coefficient of x square. Though I will write constant term by coefficient of x square. So what is the second relationship we learnt? Product of zeros is constant term by coefficient of x square. Now what is the constant term in general form of the equation? It is c. And what is the coefficient of x square in general form? A. So we have learned the relationship between coefficients and zeros of the polynomial as sum of zeros is minus coefficient of x by coefficient of x square, that is in general form minus b by a, and product of zeros is constant term by coefficient of x square, that is equal to c by a. This is how we show the relationship between coefficients of a polynomial and zeros of the polynomial. Understood, children? Now coming to the next polynomial, where we will show the relationship again between the zeros and the coefficients, where the polynomial changes. Alright, now the polynomial is written as 3x square plus 5x minus 2. Now 3 2s are 6. So we need to see, because it's a positive sign, there is no problem at all. Both are positive. Now we have here 6. So, and the middle number is 5. 6 and 1. Minus 6 plus 1 makes 5. Isn't it? Alright. Now, plus 6x minus x minus 2. Now, I just, for my convenience, I make it common. 3 implies, this implies is important, alright? Implies 3x x plus 2. Now here, when I don't have any number in common, we take 1, alright? Minus 1, x plus 2. That implies 3x minus 1 bracket x plus 2, because we are finding the zeros of the polynomial, solving the quadratic equation, we equate this to 0. Implies 3x minus 1 equals to 0, implies 3x equals to 1, x is equal to 1 by 3. Alright, and here x plus 2 is equal to 0. X equals to minus 2. So what are the zeros of the polynomial? 1 by 3 and minus 2. Now let us find, first of all, let us write the quadratic equation in general form to find out the a, b and c. A is 3, that is coefficient of x square. B is 5, coefficient of x, constant term, correct, minus 2, not 2, minus 2. Very good. Now, first of all, sum of zeros. What is the sum of zeros? The sum of zeros is 1 by 3 plus minus 2. That is 1 by 3 minus 2. That is 3 2s are 6 minus 6. 1 minus 6 is 5 minus 5 by 3. Alright. Product of zeros. Product of zeros is equal to 1 by 3 into minus 2. Whenever negative sign of a number is there, please don't forget to put a bracket, just for convenience of multiplying the sign. Now, when you don't put the bracket, there is a possibility of getting a wrong answer. That is equal to minus 2 by 3. Now, in the last, we had seen what is sum of zeros? Minus coefficient. Coefficient of x by coefficient of x square. We did this in the last quadratic equation. So that is, what is minus coefficient of x, children? Coefficient of x is 5. Minus coefficient of x is minus 5. So minus of minus 5. So that becomes plus 5. Isn't it? Minus of minus 5 becomes plus 5. And coefficient of x square, that is 3. Isn't it? So minus yes, minus coefficient of x, that is 5. Coefficient of x is 5 minus coefficient of x, that is minus 5. And coefficient of x square is 3. Minus 5 by 3. Are we able to see that both the answers are matching? So sum of zeros minus 5 by 3 and with coefficient of x and x square, we are getting minus 5 by 3. This is what is relationship between sum of zeros, that is zeros and coefficients of the polynomial. If you do the problem from the zeros and from the coefficients, you get the same answer. And this is what we need to show, the relationship between zeros and coefficients. Now, product of the zeros, it is minus 2 by 3. What was the, for product of zeros, what was the equation for coefficients? Correct. Constant term by coefficient of x square. What is the constant term, children? There, minus 2. And coefficient of x square, 3. Minus 2 by 3. Are we getting the same answer? Yes, absolutely. Here it is minus 2 by 3 where we found product of zeros, and with the coefficients we got minus 2 by 3. This is what we are showing, the relationship between the zeros and the coefficients of the polynomial. In both cases, we are getting the same answer. So this is understood? Now I'll tell you the zeros of the polynomial in general form. What do we take zeros of the polynomial as? Here we are taking it as x. I will tell you how to write in terms of alpha and beta. What are they? What do we take them as? Now the x, since it's a quadratic equation, we got two zeros of the polynomial in x. So those two we will take as alpha and beta. So the two zeros of the polynomial, as it is a quadratic equation, we take, let alpha and beta be the two zeros of the polynomial Px, where Px is equal to ax square plus bx plus C. All right. So alpha and beta are zeros. So sum of zeros is written as alpha plus beta. All right. That is equal to minus B by A. Because we had just now written it is minus coefficient of x by coefficient of x square, that is minus b by a. And similarly, product of zeros is equal to alpha beta, that is alpha into beta, alpha beta, that is constant term by coefficient of x square, that is c by a. So what we have learnt now, the sum of zeros, that is alpha plus beta, is minus b by a, and alpha beta is c by a. Is it clear? All right, very good. Thank you.